All right, so here we go, 11-1-2, day 2, because I did touch on it on 11-1-1, and anyways, you guys get the idea. Previous lesson, we touched on a lot of this. Now we're going to find out how in the heck these things could ever turn out to look like these 6 little drawings. So, I'm not going to bore you to death, so I'm going to pick one and just call it good. So we've got example 1, we got example 2, we got example 3. Oh, this should be example 3, but whatever. And then this should be example 4. So no way am I going to do all 4 of these and just waste your entire time. But I'm going to go for this one because it's the weirdest, coolest. And I don't know how much of this I'm going to do because, again, there's only so much of your concentration that I expect, but there's the math problem. So you literally, it's like a connect the dot sort of activity back in kindergarten if you know what you're doing. So we're going to put this degree measure right here in here, and we're going to figure out what this is first and then multiply it by 4. In other words, what is 3 times 0? 0. So I'm going to go sine of 0, which we should almost have memorized, is 0, times 4 will be 0. Now I'm going to go 3 times 15, so I'm putting the 15 in for theta, multiply it by 3, I get 45. So sine of 45, enter. And I got to multiply that by 4, 2.8. You can round a little bit. Now what's 3 times 30? 90. Now what's sine of 90? 1 times 4, that's an easy one, 4. Let's put 45 in for that. Well, 3 times 45 is 135. So sine of 135, enter, times 4, 2.8. Now I'm going to put 60 in there. Well, 3 times 60 is 180. So sine of 180, enter, is 0. We knew that. Times 4 is 0. You can kind of notice it finishes like a cycle. So let's plot these points. Remember, polar coordinates. R is 0. Theta is 0. That's a weird one. That's just right smack dab in the middle. 15 degrees. Now that, remember, this is 15. That's 45. This would be 75, and you might need to put those in for these. 15 is 2.8, but it's 2.8, 15 degrees. So that's my R. So it's like, 2.8 is right about there. And I need to go up 15 degrees, which is right here. Okay. And now I'm going to go 45 degrees. 30. I almost forgot this one. So that's 30 degrees. So my spinner is length 4, and I go up 30. Now I'm going to go up, I'm going to go 45 degrees, 2.8, or 2.8, 45 degrees. And so I go 2.8, then I go up to 45, right there. And as you can see, this is going like this, and like this, and like this. You can kind of see it coming back. 60 degrees, 0. So as you can see, my R is 0, and I rotate it 60 degrees, which is kind of pointless, because if my R is 0, and I spin it 60 degrees, it's just stuck. So that means come on back, and there's a leaf. And I'm going to go a little bit further and just pull the plug on this. I think you guys are going to get the idea. So 75 times 3, better do this, is 225. So I got to go sine of 225 and then multiply that by 4. Negative 2.8. I'm glad I kept going. 90 times 3 is 270. And I get negative 1. But times 4 is negative 4. 105. 105 times 3 is 315. So sine of 315 times 4, negative 2.8. 120 times 3 is 360. So sine of 360, which is 0, times 4, is 0. So we're going to start another cycle here. But we got to be careful. We got negative r's, so we got to be very careful here. So we got negative 2.875 degrees. Remember, we got to ignore this for a bit. So we go 2.8, which is back to here. We go to 75 here. But then because of the negative, we got to go completely opposite back down to the 2.8. It's right there. And, okay, let's just keep going. So 90, negative 4. So this is negative 4, 90. Ignore the negative. So my spinner's 4. I go up to 90. But because of the negative, I got to go completely to the opposite side, which is right here. And then I go 105. Well, I'll write negative 2.8, 105 degrees. So 2.8, ignore the negative. 2.8 is back to here. 105 would be 90 plus 15. 15 would be right here. And then because of the negative, I got to follow this line all the way to here and right to there. And you can see it is just another leaf. And I don't want this to be a cop-out, but if you just keep going and keep going, you're going to end up with probably another leaf here. And then other numbers might just start repeating the petals. So that's how you do it, and it's quite a job. So I think you guys get it. But we got some time, so let's do it. 135, I'm going to go 3 times 135, enter. Now I'm going to go sine of 405, enter. That's 0.707 times 4. Here comes that 2.8. 150 times 3 is 450, so sine of 450 times 4 is 4. Guess what this is going to be? I bet you it's 2.8. 165 times 3, enter. So sine of 495, 0.707 times 4, there it is, 2.8. And let's just finish with this one. 3 times 180 is 540, so sine of 540 is 0 times 4 is 0. You can see another cycle. So 2.8, go out 2.8, spin at 135. Where is that? Well, that'd be right here. It's 90 plus 45, so that'd be halfway. That means it's right here. But my spinner is 2.8, so it's 2.8. You stay right on that sort of line there. And there it is, 154. So I go out to 4, I go 150. That would be right here. So 4, 150 is right here. And then I go 165, where's that? Right here. These are little 15-degree increments. 2.8, so 2.8, sound effects help, and then right about there. And then this one, 180, so we go, well, our R is 0, so it's right here. Spin at 180, you're stuck. So that means we go out like this, and like this. And what I'm saying is if you keep going, it's just going to take you back over one of these leaves. Because right now we've got perfection. So, sorry if that is like, man, you didn't finish, but I think you guys get the idea. So you just got to keep going until you're done. All right, so that's it for this lesson, I think. Oh, no. No. Okay. Wow, that was almost really bad. So, this huge section on how to use your graphing calculator. I forgot all about this. So, get your calculator out, and we're going to walk through this because this gets a little crazy. But I've got everything listed for you, but let's do it. So, converting a graphing calculator to polar mode and graphing mode. So that crazy thing that I just did we're going to tell our calculator to do it for us. So let's just follow this, see if we can make this work. It says go to mode and make sure you highlight degree polynomial. So you can see degree polynomial. So mode, I've got my degree, but I need to, I don't mean polynomial, I mean polar. So bing, 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 enter. So there we go. We've done that. Let's go to the next one. It says go to window. So let's go to our window. And we got to duplicate these values here. So theta minimum, which means, you know, from 0 is how far we're going to spin our spinner, up to 360. So we got to clear that out. Go 360. It means 1 revolution. Steps are 5. Now, that just means our increments are going to be in 5-degree increments. X minimum, let's just follow this plan here. It's going to be -6, and then our X max is going to be 6. Our X scale is 1, -4, 4, 1. So all this needs to be like that. And then let's go on to the next step. So this says set up table by selecting second, then window. Notice above the window it says table set. So let's clear this. Whoops, I didn't mean that. Max was 6. All right, so second window. And now we're going to get this weird looking thing over here. We got to make sure that table start is 0. And then go down here to 5. And then auto, and select values just like we did. Now it says go to format, which format you need to select second, then zoom. Format's right up there. So second, zoom. Now you've got all these crazy things. Polar, right there, so hit enter. And then we need label on. So if we go down here, we want that on. Everything else looks good. Some of these options are here, but they're not here. So we're going to go with that. Don't care about the color, and we'll just go there. Hold on a second. All right, now we're going to go to the y equals. And we should notice plot 1, plot 2, plot 3, and that's what we have. Now we're going to type in this one that we just did, which is good. That was just lucky. So we're going to go 4 sine 3, and then theta, we're just going to, I'm going to hit that as x, and it just puts in the theta for me. And then I'm going to hit graph. Oh no. Alright, so we got to fix our dimensions. Give me a second. Let me find out where I screwed up. Alright, so I just investigated this. I hope it works, but the calculator said go to second stat plot. So second y equals, which is going to give us stat plot. I don't know what this means, to be honest with you. But then it says change it from plot 1 from on to off. So I'm going to select 1, and I'm going to go to off, hit enter, and now I'm going to go to y equals. There's my graph, say a prayer, graph it. Wow, that is okay. Pretty cool actually, but that's not what I expected. What we got was this clover thing that went out like this, and like this, and like this. So I'm not sure what's going on, but that's pretty cool. That's the first time I've ever seen that thing. Give me a second. Okay, in my investigation I forgot that just experimenting with it, I moved it back to radians, even though it says to have it in degrees. And that's what messed up this whole graph. So I'm going to select enter on the degree thing, and now I'm going back to the graph, and there it is. Come on, there it is. All right, so still working my way through this calculator just like you guys are. And that's the graph there. One more set of instructions and then we'll be done here. So we got the right graph, bingo. And now to determine the polar coordinates, remember polar coordinates are r, theta, and we can find the polar coordinates anywhere around here. It says select the trace key. Trace key's right there. Boom. So I got this little blinky thing. And I'm going to move it around. It says move it to the right. Remember the 5 we put in? These are 5-degree increments. So if I hit it to the right, now that is, my R is 1.03, and I'm up 5 degrees, barely spinning up. And if I go again, it's up 10 degrees. But now my R is length 2. You can see that it kind of is. So it's like R is 2, up 10 degrees. And if I just keep going all the way around, so there's my R is 4, and my spinner has been spun up 30 degrees. And I just kind of keep moving around, and it will take you right around that thing, and it will tell you all the polar coordinates in 5-degree increments. And that finishes the lesson, except this. Make sure to fix the calculator by going back to mode and select function. So mode, or else everybody's going to have a panic attack, and highlight function, and now everybody's calculators will work in other classes. Thank you for doing that. All right, that's it, you guys. Good luck on your homework. A lot of it is just how to use your calculator, just working your way through it. So hopefully by me making mistakes, you learn what not to do. All right, good luck.